Wow, handing in a paper with just your name on it. Valedictorian material. They should go run for president. Hi, this is Hollywood Slay Math. Did we get some of those little winners? Stay positive though. You know, they have some type of talent. We just have to find it. Stats 9.3, pulling it all together, which method? So now we got to figure out what we need to do. So we click on here and click the data table. We're going to open StatCrunch right here. We're going to click done. Now, the first thing they ask us, first of all, we don't need StatCrunch for that, but the variable pitch speed is a quantitative variable. This is important to know because the confidence intervals for a mean are constructed on quantitative data, while confidence intervals for a population are constructed for qualitative data with two possible outcomes. So that's just the definition that you have to know. Part B, to get this little plot, we come over here and we open up StatCrunch and we do graphs, QQ plot, and we click both of these, compute, and then we figure out which one it looks like. And remember, this is a little bit closer in because the values go to 100 instead of 96. So it's going to be squinched up a little bit more. But it's still easy to compare because this one you're looking at, this goes to 96. So it's not over 100, and this is over 105. So this is why we go to this one. Then, since the absolute value of the correlation coefficient, which is 0.986, correlation coefficient between the expected z-scores of the outcomes observed is 9.8. Well, we rounded to 9.85, so they would have allowed 9.86, which is what we got in StatCrunch. So that would be okay. It exceeds the critical value, and we get the critical value from the critical value table with 15 items. So the critical value table is not what we were looking for. Critical values, we look for 15, and it's 0.514. So it exceeds the critical value of 0.514 and is reasonable to conclude that the data came from the population that is normally distributed. To get the box plot, we go to Graph, Box Plot. Click the vars, draw horizontal boxes, and then we match up the box plot. Remember, we look at the mean, so between 9.45 almost to 9.90, almost to 95, and it's about evenly distributed. So this is middle of 95, and it's evenly distributed. So that's our box plot. An interval can be constructed because the data are approximately normal and there are no outliers. Remember, on the box plot, there will be dots randomly scattered over here if there were outliners. Now, to get the interval, we go to Stats, T-Stats, one sample with data. Click here. Confidence interval is 95%, and it's always we can be 95% confident, or one can be 95% confident. We're looking for this confident word. So we go and put 95% in here, compute, and it gives us the lower and upper bound, 94.42 and 95.22. The interval for all pitches in a leak would be wider because the variability of pitches is most likely greater. So if you're going with a bigger range, it's going to be wider and greater amount of data. Make sure to follow.